Okay, video 2, left off at the wind control charger. I was going to back up this diode. I bought it off eBay for $20. You want to have this mounted to wood or a non-conductive material so it don't short out. My board has a metal backing, so that's why I mounted that onto the wood. This cable too, this welding wire cable number 4, you want to use that because it's nice and flexible and it's weather resistant and it's really easy to work with, so use that. This Missouri Wind and Solar volt amp meter, I think that was around 40 bucks. It's a really nice meter, so when I have it on battery I can tell what my volts and amps are. The grid tie inverters, I think the wind was $180 and then the solar was $140 off of eBay. I love eBay. And the Intronics was $325. You can go to any of the web, like the Google Intronics, and you can look up all the specs on it. But okay, so we left off on the wind control charger. This thing will handle 440 amps, which is a huge amount. The power we left off was coming in from the wind to this part of the relay. Now the current, when the battery is charging, is running through to this, which goes directly to the positive bus. So that current's flowing in until this controller, which is hooked to the positive negative of the bars, the bus bars, controls this relay. It tells it what to do. It tells it to open or close down here, and it tells it to open and close up here. So when the battery reaches 12, or what is it now, I forget, 13.4, 13.5, the current will flow and it will disconnect this from the battery, and it will divert the load through directly to the grid tie. So that way, instead of before I had that, so it diverted to the load, the resistors up here, but now it goes to the grid tie, so I'm not wasting that energy.
And hopefully if you're a smart therapist, you say it at the right time when they can take it in, and you say it in a way where they can consider the words that you're saying. But they're private. Now I know you do. I do marriage counseling.
The load, this load now is connected to the wind grid tie inverter. So if this power goes out or this malfunctions, the grid tie, then the load will then get diverted from this up to here. You want your wind turbine to be on a load at all times so it don't freewheel. If it free spins, it could burn up your wind turbine. So you want that under a load. Go back down to the wind. The negative of the wind will come in here, and it goes out and directly to the bus. So your wind negative goes to the bus. If we switch this We'll go back down. This is the wind. We were on battery, so we can switch it to off. Now we'll go directly to the grid tie. That disconnects this. The number 1 position, the battery, and what happens then is that wind comes, the positive comes in through the breaker, comes in, and it goes directly to the grid tie. So I won't be using it for my battery to charge my batteries if I have it on the number 2 position. The negative from so the positives to the wind and the negative goes directly to the battery again. And then the dump load directly to the dump load. The dump load terminals, I guess it's called the fault output. These little breakers, by the way, I bought on eBay also. They're 100 amp breakers. And I have that hooked right after the on-off switch to the battery. I have one of them there. Okay, now we'll go to the solar part of it. The solar will come in. The solar doesn't need to be connected to a load. It can just be disconnected. So it's a little easier. So I'll have my positive bus, my negative bus. The positive bus the wind or the solar panel will come in. It'll go through another one of these. This is a 100 amp breaker. Goes in, goes through, and it goes to the common of this. I call it my solar switch. So I could have the solar panels on battery, off, grid tie, or grid tie and solar at the same time. Same as the wind. We'll go to the battery, and that goes in to the common. Here's the solar coming in. If it's on one, comes out and it goes directly to the MPPT control charger, and this control charger just controls the solar.
It's an unsustainable model. Student debt is the fastest growing component of the household balance sheet, expected to top $1 trillion this year.
I think I already said this. This was like $325.
Yes. So as the government continues to hand out this easy money, students are taking advantage of that.
I'll upgrade later if I have to, but for now this is good enough for me. It wasn't quite as expensive as some of the other ones. This one's made in USA. It was a little hard to get this number 4 cable into their terminals. They're a little small, but I did manage to push them in there.
You know, it doesn't take a rocket scientist, Gary, to figure out that if the government's going to keep increasing college loans, the colleges are going emboldened to keep increasing tuition.
Of course, this control charge, you have positive, negative, goes directly to the bus bars, and the negative goes directly to the wind bus bar. Right here. So the negative goes in to the negative from the solar, and then the positive goes to the battery switch. So in that that will be charging the batteries. And of course, if I switch it to the grid tie, the power will be going into the grid tie. Number 2 goes around and hooks to the positive of the grid tie. The negative goes to the negative battery.
So 75% of students attend public universities, and that's where this hit is really happening. What the federal government is attempting to do is to slightly decrease the amount of money that collectors are making.
Trying to think if I forgot anything.
Going from 16% fees to 11%.
Probably did, but
And they do want to prevent defaults. They want to ensure
any comments are welcome. If you think I'm crazy, that's fine too. Let me know.
so that we are preventing the cycle of default, which benefits everyone.
There it is.
But allowing students who are not able to get a job or who have
I also bought these two in soup. What are they called? In soup